Hello everyone, my name is George Dosu and I'll be presenting to you my research on effect of dietary ginger root extract supplementation on growth performance and delayed type hypersensitivity response in broiler chickens. I have here my outline starting from my introduction, then the rationale behind the research, the objectives which were investigated, as well as my materials and methods which were used to carry the research, the result and discussion, as well as my conclusion. So poultry production in the US has been on the rise, and particularly US is being noted for being the second leading producer of broiler chickens next after Brazil. And this is very evident in the first chart, which indicates the first top 5 states which are making significant contribution to this factor. We have Georgia, Arkansas, Alabama, North Carolina, and then Mississippi. So we look at the second chart, it pretty much illustrates the market opportunities with respect to chicken, which is actually very tremendous since it has, very high nutritional source of protein as well as very few religious restrictions compared to other animal proteins like pork and beef. And particularly, Americans consume more chicken than anyone else in the world. So this kind of like tells us a story of how poultry in general has been accepted and being consumed worldwide. So as we all know, there is this trajectory of increasing population worldwide. And since population is increasing, there is equally going to be a high demand for food. But also it is very instructive to note that infection rate is very high in poultry birds, especially the newly born chicks, because of their weaker immune system at a young age. So they tend to present themselves as a significant reservoir of certain pathogenic diseases such as Campylobacter, Clostridium, Salmonella. And actually, there is still a lot of effort being made to control this situation in the poultry industry. Even though there has been a use of antibiotics, biological and chemical products, or even vaccines, then there is still a major cause of this problem still lingering around the industry. And therefore, it is, however, very imperative to conduct a study to look into other alternative ways by which infections or pathogens causing foodborne illnesses could be eliminated, and also to use feed additives that is capable of stimulating the bird's immune system without compromising on digestive function and growth performance of the birds. So this is why I'm looking into dietary root extract as an alternative to antibiotics in poultry production, because it has so many multifunctional roles in their host organisms. And what are these multifunctional roles? So ginger can be nutraceutical. By that, it helps to reduce heart-related problems as well as metabolic disorders. It also has antioxidant properties, which helps to stimulate the immune system and then the digestive efficiency of the birds. Ginger also possesses anti-inflammatory and antimicrobial properties as well. As we all know, there are a set of healthy living microorganisms such as lactobacillus and bifidobacteria living in the birds. And what ginger does is it helps to reduce the pH in the microbiome, which helps to improve the nutrient utilization. Ginger also has properties of nutrient metabolism, and that's particularly because it possesses a set of phenolic compounds such as shagaos and gingerols, which helps to reduce the cholesterol level and serum in the egg yolk content. Another missing important properties of ginger is its anti-apoptotic property. That helps to decrease the activity of certain proteins that could contribute to development of cancer. The aim of this research was to determine the optimal dietary inclusion level of ginger to broiler chicks and to see how that would improve their growth performance and enhance their delayed type hypersensitivity response. And this research is necessitated due to previous researches which have stipulated that the use of antibiotics is making pathogens develop antibiotic resistance, and as well leaving residues in animal food products. The 6 weeks experiment was performed in the Poultry Research Unit at North Carolina A&T with 432-day-old chicks, specifically Ross 708 strains, which were obtained from the commercial hatchery. The experimental design included 6 treatments by 6 replicates, in which all treatments had 12 birds per pen. The first treatment, which is the control, had no GRA added to their diet. The treated groups include the MX, which is the unmedicated soybean meal treated with bacitracin methylene disalicylate. GRA1 are those diets which have ginger added at 0.375 concentration. GRA2 are diets with ginger added at 0.75% concentration. GRA3 are diets added with ginger at 1.5% concentration. And GRA4 are those diets which were added with ginger at 3% concentration level. All these birds were allowed free access to water and feed throughout the trial phase. Growth and health parameters included body weight, weight gain, feed intake, and feed conversion ratio, whilst the delay type hypersensitivity test was analyzed by measuring the toe web thickness. Growth and health parameter: all chicks were housed in the battery cages in the poultry unit and fed with starter diet for their first 21 days of age, and was later transferred to the floor pen unit where they were fed with grower diet between 22 to 42 days of age. And all chicks were checked twice daily, and mortality was monitored accordingly. For the DTH analysis, a 5 mg stock of Phaseolus vulgaris P was reconstituted into 5 ml of sterile PBS solution to give a final concentration of 1 mg per ml. During injection, birds were restricted movement. Alcohol swabs were gently rubbed to sterilize the toe web areas between the second and third digit feet before injection was done intradermally. So the PHAP was injected into the right foot, whilst the sterile PBS was injected into the left foot as a control foot. The toe web thickness was then measured between 24 hours and 48 hours interval using the micrometer screw gauge. So the growth performance, which is pretty much the way back, was measured on day 7, day 21, and day 42. And then the DTH response was done on day 24, whereby the post-PHAP injection was measured at 24 and 48 hours. All experimental data were collected and subjected to one-way ANOVA, whilst the significant statement was defined as P, which is less than 0.05. So my objective 1, did ginger root extract as a dietary supplement improve growth performance in broiler chickens? So at the end of week 6 for the growth performance, the body weights along the columns for all treatments indicates that GRE1 and 2 are similar to the MX and then the con treatments. However, we would see that GRE4 was sharply declining in body weight. The same applies to the body weight gain. Looking at the columns with all treatments, we realize that GRE1 and 2 are similar to MX but significantly superior than the control group. Feed intake in all treatments was not significantly different. But looking closely to the FCR, we realize that GRE1, 2, and 3 showed similarities or are comparable to MX. However, they were far superior compared to the control groups. So in summary, did GRE inclusion enhance growth performance? Addition of dietary ginger root extract did not affect the overall feed intake. Body weight gain increased with increasing the GRE concentration up to 0.75%. GRA supplementation showed superior FCR in treatments than in control group. Except for GRE4, GRA up to 1.5% showed FCR, which is comparable to MX treatment. So in Objective 2, the ginger root extract as a dietary supplement enhanced delay type hypersensitivity response in broiler chickens. So the result here for DTH response in 24 hours indicates that GRE1, 2, and 3 showed superior significance compared to control, although they were similar to MX. So in summary, the GRA inclusion improved DTH response, except for GRE4. GRA up to 1.5% was superior to control group, although they were comparable to MX in DTH response. In overall, ginger root extract supplementation improves broiler performance. The results suggest that a more improvement of growth performance parameters were superior at 0.75% levels. The body weight, feed intake, and feed conversion ratio reduces with increased supplementation of ginger at 3% level, and this could probably be due to the subsequent reduction in weight gain as the inclusion levels of ginger were increased. It was also observed that MX and GRE2 treatments recorded higher FCR than the broilers in the control, and this could be due to the BMD incorporation in MX diet because BMD has composition of compounds that serves as growth promoters. For the DTH analysis, ginger root extract showed comparable results to the MX. However, GRE1, GRE2, and GRE3 treatments recorded higher DTH response compared to the control at 24 hours. And this could be due to the increase in T-cell immune responses and also high antioxidant and biochemical properties of ginger. So in conclusion, GRA supplementation at 0.75% levels is beneficial to broilers as it improves growth performance and enhances delay type hypersensitivity response. And this research with the result is very important because it helps to carefully evaluate the inclusion level of ginger in the diet, which is very best optimum and safe for poultry. This will provide enough basis for feed producers and researchers in planning and designing poultry diets in the next future. So these are my references. So I'd want to acknowledge my advisor in the person of Dr. Yewande Fasina for helping me to carry out this research, and also my colleagues in the Poultry Mononutrition Lab and Research Unit in A&T, North Carolina, for putting up a very good contribution and supporting me throughout this process. I would also want to say a very big thank you to Ag Research for funding this whole research. Thank you.